Welcome everyone, and thank you for joining us today. I'm excited to introduce our presentation on the Bitzer Screw Compressor CSH9583-140Y-40P today. We'll be exploring various aspects of this compressor, including its design, calculation, main parts, manufacturing, installation, and operation and maintenance. Over the next few slides, we'll take a closer look at each of these topics to give you a comprehensive understanding. Let's get started. Let's take a closer look at the compressor design concept. The type we're focusing on here is a semi-hermetic twin-screw compressor. This design is quite popular because it offers a good balance of efficiency and reliability. The working principle behind it involves gas being compressed between two rotors, specifically a male and a female rotor, creating a sealed compression chamber as they turn. In terms of refrigerants, this compressor can handle several types, including R134A, R407C, and R22, depending on the specific model and application. This flexibility is important for different cooling needs. Now, when we talk about the formula for compressor power, it's P equals letter 1E41 times the difference in enthalpy between the outlet and inlet points, or P equals letter 1E41 times H2 minus H1. This helps us understand how much power the compressor consumes during operation. Finally, efficiency is a key point. It's calculated as the cooling capacity divided by the input power, multiplied by 100%. This tells us how effectively the compressor converts input energy into cooling performance. Understanding these concepts is fundamental to optimizing compressor operation and overall system efficiency. Let's walk through a practical example to better understand performance and calculations. Suppose we have a refrigeration load of 350 kilowatts. Now, if the coefficient of performance, or COP, is 3.5, we can determine the input power by dividing the load by the COP. That gives us about 100 kilowatts of input power. Next, to find the compressor's horsepower, we convert that power from kilowatts to horsepower by dividing by 0.7457, which results in approximately 134 horsepower. This matches quite closely with the specifications of model CSH9583-140Y-40P, showing how these calculations tie into real equipment. And as a quick recap, the key formula here is that horsepower equals the heat load divided by the COP, then converted from kilowatts to horsepower using that factor of 0.7457. This example highlights how understanding these relationships helps us evaluate system performance and select the right components for efficient operation. Now, let's take a closer look at the main components that make this system work so efficiently. First, we have the twin screw rotors, which are designed as helical male and female rotors. These are crucial because they create a precise, continuous compression process. Next, you'll notice the suction and discharge ports. These are the entry and exit points for the fluid, ensuring smooth flow through the system. Moving on, there's the built-in oil separator. This component is essential for removing oil from the compressed gases, helping to maintain the system's efficiency and prevent contamination. The motor housing and terminal box are also vital. They protect the motor and provide the connection points for electrical power, ensuring safe and reliable operation. Additionally, there's the oil pump and filter, which work together to circulate and clean the lubricating oil, extending the lifespan of the system components. Lastly, safety valves, pressure sensors, and thermistors are integrated throughout. These elements monitor the system's pressure and temperature, providing critical safety measures and real-time data to prevent any potential issues. All these components work together seamlessly, supporting the overall theme of reliability and efficiency in this compressor system. Let's take a closer look at our manufacturing and quality processes. We start with CNC-machined rotors, which ensure high precision and consistency in every component. This advanced machining technology allows us to meet the strict specifications required for optimal performance. Next, we apply a hard chrome coating, which not only enhances durability but also provides corrosion resistance. We also maintain tight tolerances, specifically less than 20 micrometers, to guarantee perfect fit and function. Our products undergo pressure testing up to 30 bar, following ISO standards, to confirm their reliability and safety under real-world operating conditions. And finally, we conduct factory performance testing based on industry benchmarks like ASME PTC 10 and ISO 917. This comprehensive testing ensures each unit meets our high standards for quality and performance before reaching our customers. All these steps are crucial in delivering products you can trust, aligning with our overall commitment to excellence and precision. Let's now discuss the installation guidelines to ensure everything runs smoothly. First, it's important to mount the equipment on vibration isolators. This helps reduce noise and minimizes vibrations that could affect performance. Next, you need to pay attention to proper oil charge and refrigerant piping. Correct oil levels are crucial for optimal operation, and proper piping ensures efficient refrigerant flow. When it comes to electrical connections, always follow the Bitzer manual, especially since we're dealing with a 3-phase 400V system. Proper wiring is essential for safety and reliability. It's also important to align the unit with the oil separator and condenser to make sure everything fits and functions correctly. Lastly, don't forget to install the LP and HP switches, along with the discharge temperature sensor. These components are vital for monitoring and protecting the system during operation. Following these guidelines ensures a safe, efficient, and reliable installation that supports the overall performance of the system. Let's walk through the starting procedure to ensure everything runs smoothly from the outset. First, we perform a pre-check, which includes verifying the oil level, conducting a pressure test, and a vacuum test. These steps are essential to confirm the system's integrity before starting. Next, we initiate a soft start sequence, typically using either a DDC or VFD to gently bring the equipment up to operational speed, reducing stress on the components. It's also crucial to record the initial suction and discharge pressures, as well as the current draw. This baseline data helps us monitor the system's performance right from the beginning. We then make sure that the discharge temperature stays below 100 degrees Celsius and that the oil return is functioning normally. These are key indicators of the system's health during startup. Finally, we log all the initial performance data. This initial logging provides a reference point, making it easier to identify any deviations or issues later on. Overall, following these steps carefully helps us ensure a safe, efficient, and reliable startup process, which aligns with our goal of maintaining optimal system performance throughout operation. Now, let's talk about operation and maintenance. It's essential to perform routine inspections every 2,000 hours. During these inspections, you should check the filters, verify the oil level, and conduct leak tests to ensure everything is functioning properly. Oil changes are recommended approximately every 8,000 hours or once a year, whichever comes first, to keep the system running smoothly. It's also important to regularly check the motor insulation and listen for any unusual bearing noise, as these can be early indicators of potential issues. Additionally, recording trends such as pressure, current, and temperature helps us monitor the system's health over time and catch problems before they escalate. Finally, always use Bitzer-approved oil, specifically BSE 170 for R134, to ensure optimal performance and compliance with manufacturer specifications. These maintenance practices are key to extending the lifespan and maintaining the efficiency of our equipment, aligning perfectly with our overall goal of reliable, cost-effective operation.